All right. We're back with chapter 11 after a fantastic dance video party that challenge that nobody took me up on, I mind you. No worries. Yo, I can't shake it like your boy. I got it. What we have is simplifying radical expressions. This is not finding decimal solutions for each of these. In all of these problems down here, we have perfect squares hiding inside the radical. I'm gonna do a couple from the top real quick just to get through it, but it really doesn't have much to do with the bottom. Real quick, square root of 225 plus minus 15. Work inside the radical. 49 is 7 times 7 plus 576 is 24 times 24. That gives us 625. And the square root of 625 is 25, okay? We're good there. More of the same, more perfect squares. The perfect square of 4, 2, 100, 10, and then reduce your fractions still, 4th grade, 1/5. Okay, that has nothing to do with the rest of the page, so ignore this top part over here. Let's just get to work on the business stuff. I'm gonna jump around a little bit and leave you guys the rest, okay? No calculator. Do not, if you need one, to see what's hiding inside, but there's perfect squares hiding inside 32. So you gotta go through factors of 32 that it might be perfect squares. So you say to yourself, okay, 4. 4 is a factor of 32, but it's not the biggest possible one. Let's use 16. So what I do is this. I'm gonna go big radical, 16 times 2. And that's the tricky part, because some of you might have said, oh, I can use 4 as a perfect square, but you want to use the biggest possible one. 16 times 2, 32. 16 is a perfect square. It breaks out of the radical. So our final answer is 4 root 2. So figure out the perfect square inside and then break it out as that perfect square. As you can see down the list here, I made you a nice little cheat sheet of perfect squares, if you can see it. 1 times 1, 4 times 4, 8 times 8, etc. So I went through 10 because I think that's all you'll need. All right, let's jump to number 8. Only one perfect square hiding inside of 28. That's our 4. 4 times 7. Okay, 4 is a perfect square. Square root of 4 is 2. We're talking 2 root 7. Nicely done. Okay, watch this on 9. When it comes to the variables, it's a very different approach. What you got on the outside of this radical is inside that little shepherd's crook there is like a little 2. It's a unspoken 2. We don't really mention it because it's always there. So we don't write 2 outside of, or into these little crooks of all the radicals, because we know it's a 2. So that's like a unwritten rule. So if it's $2 to get into the club, X to the 4th walks up to the door, bouncer says $2 to get in, X says I got $4, 2 X's get in the club, okay? So it just divide, 4 divided by 2 is 2, outside the radical. Y walks up to the door, the bouncer says $2 to get in. Y's got $3, okay. 1 gets into the club, but wait a minute, 1 has to wait in the car. So it has to go in perfectly, or the remainder waits in the car. Let's try another one of those right below it. Let's do number 12. Click back to perfect squares. Square root of 36 is 6. X to the 4th walks up to the door. $2 to get into the club. 2 X's get in. Y5 walks up to the door. Bouncer says $2. 2 Y's get in, but we got a remainder again, and that remainder waits in the car. Okay? Go back to some more math. just numbers now. We got 45. Perfect square hiding inside of 45 is 9. And you'll get good at this. There's a rhythm. You'll catch a rhythm to this stuff. Looking for perfect square. It's kind of a little fun little game almost. We're talking 9 times 5. Square root of 9 is 3, breaks out. 3 root 5. Okay? 147. Not difficult. That might spend you a minute or two to find. But you know that 49 times 3. Aha, sneaky. See, 49 is a tough one. It shows up once in a while. 49 times 3 is 147. 49 breaks out as 7. We're talking 7 root 3, okay? Looking for perfect squares. Go to work. Nothing for 7. That's okay. Chilling. On top. Stay in the radical. But 25, 5. So root 7 over 5. So sometimes no one breaks out and it happens. Here, let's work inside the radical first for number 14. 3 divided by 27 is 1/9. And then $2 to get to the club. Actually, let me just reduce these first. It's even easier. B2, these guys subtract. This guy goes away. B4 becomes B2. And then it's B2 still under the radical. $2 to get to the club. I got $2. 1B gets in. Okay? Okay. Play around with the rest of these. You got just 15 through 21. Here's 22. If you want to see the word problem, if you can see it. Let me try it like this. Let me go like this. Here's 22. 5 miles an hour south. So, and there's from noon to 4 p.m. Here's the ranger station. 5 times 4 is 20. And then this guy goes 3 miles an hour east. 3 times 4 is 12. So we got here's a little Pythagorean theorem. But you'll do this next year in geometry. 20 times 20, because we're going to square these, that's the Pythagorean theorem, is 400 plus 144, 12 times 12. Those numbers combined are 544. And it asks for the estimate the distance. So this one will actually find the perfect square. And then the square root of 544 is 23.3. And that's this side length right here. But you'll do a lot of this next year, so don't worry about it. Okay, so for tonight, do Friday, please. Just knock out, practice. I can post these answers too if you'd like me to. Try 15 through 21 tonight. Seeking perfect squares and getting people into the club. Some people gotta wait in the car. It happens. All right, love all, be well.